So let's get an example here. I just wrote down the steps. Here's our example. F of x equals x minus 1 squared, x plus 4 to the third power. So let's just go through those steps. Question: is it factored? Yes, it is factored. I know it's factored because it has parentheses. Okay, next thing, basic graph. Well, a basic graph is looking at the exponents. Now, you could expand this, right? X times x minus 1 times x minus 1, and then you would do 4 on the box, and then you would multiply by x plus 4, and then x plus 4, and then x plus 4. That would be pretty crazy, right? So, just generally, this is not algebraically accurate, but essentially what we're doing here is we're just going to get an x squared. And here, this is going to be, again, this is not a property of exponents, but what we're doing is we're just kind of getting a basic graph. X squared times x to the third is x to the fifth. And what does that basic graph look like? Class, is this odd or even? This is an odd. What's the easiest odd degree function we know? X to the first. So that's going to start down and up. Okay? So I know my graph's probably going to look something like craziness like that. Okay? It's going to start down and then end up. So that's just basically what a basic graph looks like. Okay? And we're going to sketch it more with more details. Let's go through the multiplicity now. With the multiplicity, we're going to do the zero product rule. So I'm just going to set one of the parentheses equal to 0. And the reason why I'm not going to write out every single one, x minus 1, and then x minus 1 equals 0, I don't want to do the same problem twice. Does that make sense? And then I have x plus 4 here equals 0. And then to solve here, you just add 1 to both sides. Therefore, x is equal to 1. So let's write that. One of my zeros is x equals 1. Let's make a chart. Let's write the degree. And then we'll write if it kisses or shoots through. Okay? Over here, I'm just going to subtract 4. So I have x equals negative 4. Okay, so we've basically done the zero product rule. Okay, let's look at x equals 1. So this is a big idea here. Okay, x equals 1 is the same thing as the binomial x minus 1. X equals 1 is the same thing as the parentheses x minus 1. I just showed that to you, right? So we look at its multiplicity here. Multiplicity, let's write that. Another word for its degree is its multiplicity. Let's put a 2 here. Class is 2 even or a odd number? And what do you do at evens? You kiss. X equals negative 4. What's its multiplicity? It's a 3. 3, is that an even or odd? You're going to shoot through. In this problem, there are no transformations or shifts. What that would basically look like if there were some a values in the front, like a constant, or another constant back here, like a minus 8. So we don't have any of those. Let's go ahead and graph this now. I know on my x-axis I'm going to have a 1 and a negative 4. So let's kind of plan for that. And kind of more on my left side. Alright, let's graph x equals 1. This was here. x equals -4. So x is equal to -4 here. And the basic graph here, basically, it's really talking about its end behavior. So we talked about how it kind of starts down and ends up. So in our problem, it's going to start down and end up. And then you're going to take a pencil. Everyone say pencil? It's just easier if you do pencils. Okay? So here's my arrow. My end behavior starting there, and it tells me to shoot through, so I got to go through the yellow point. And then as I approach the pink, it says to kiss or bounce off. And then I'm going to finish by going up. Okay? And basically what we did here is we just basically sketched a polynomial without using our graphing calculators. That's the goal. So we can actually verify it on our calculators. I think on this next quiz, I'm going to say no graphing calculators. So if you've been kind of just like having the calculator pass the class, that's a bad thing. X plus 4 to the power of 3. Can't see anything because of my reflections. Presume 6. And at least we have a basic idea, right? It shot through. It went up super high, comes back down, bounces. And I can kind of tell my graph up here is not as accurate because there should have been more turning points. Okay? But the big idea is that we're just looking at what's happening here to kind of give you an idea. Let's change the window. Ymax 100, 10 graph. Okay? So that's how you graph a polynomial by its x-intercepts.